All right, so carrying on with Learning Guide 5, which remember guys, the whole point of this Learning Guide 5 is to be able to draw a graph very specifically, very accurately without the use of technology. So we're going to talk about something really important in this lesson 3, which is the first derivative test. And the first derivative test is basically a way of seeing where is my graph increasing and where is it decreasing? Where is it going up? Where is it going down? And so we all know that first derivative is slope. And remember, slope tells us our rise and our run. So basically, am I going up or am I going down? So we can kind of simplify that in and summarize that in these first 3 little boxes here. If our first derivative changes from a negative to a positive slope, then obviously we must have a minimum value at that critical value. So remember that critical value we talked about in that last lesson. Critical values I mentioned are so important. We're going to use them again and again. And you find that from the first derivative. And this first derivative test again is going to tell us, okay, well, what does our graph actually look like? Again, so here and here, even though that looks like kind of a weird, cusp, it's still going to be a minimum value. Obviously then, if our derivative changes from positive to negative, then we know that we're going to have a maximum. So if I find one slope and it's positive, and I find another slope and it's negative, that critical value that's right in the middle there is going to be a maximum. The last one, which is a little bit different, it's saying if our derivative does not change sign at c. So for instance, if I've got a negative slope, and then I have another negative slope, and don't worry guys, we'll practice this if it's not making sense yet. What this is going to be called is an inflection point. So that means that this is going to continue to go down regardless of that c. Or again, this is a positive slope and a positive slope, and again, this is called an inflection. Okay, which is basically a change in concavity, which is what we're actually going to get to in the next lesson. All right, so how do we test for this? Well, the first thing that we always want to do is find those critical values. And remember, we practiced that already by finding the first derivative and setting it equal to 0. That's pretty much always going to be your first step here. All right, so number 1, find our CVs. So let's take the derivative. Okay, so I've got 4x minus 16. To find that critical value, remember we plug in a 0. And we've got 4x minus 16. We add our 16 to both sides, divide by 4, so x is going to be equal to positive 4. Now this critical value, what we want to do now is basically one method, and you might learn another method in class, but we want to put that on a number line. And what we want to use is some test values. Because remember, let's say for instance, if I get a positive slope here and let's say a negative slope here, that must mean that 4 is going to be a maximum. Or vice versa, let's say if I plug in some test values and I get a negative here and a positive here, well, that must mean I've got a minimum at 4. So let's see what that looks like. Okay, or obviously the last one would be an inflection. So number 2, put our critical value on the number line. Check, we've done that. And then use a chart, which your teacher might do with you in class, because like I said, there's 2 ways of doing this. Or we can just use a test value. So in the podcast, I'm going to use a test value, just so you can see a couple different methods. So a test value is basically, I'm going to choose a number that is less than 4, first of all. So any number less than 4. Well, obviously 0 is probably a really good number to choose. So I'm going to take my derivative and I'm going to plug in that value. Because remember, we want to see what our slope is. Now, this is our equation here. So I've got 4 times 0 minus 16. So we've got negative 16. Now guys, I don't care about 16. It could be negative a million for all we care. All we care about is that it's a negative. If this is a negative, that tells me my slope on the graph is decreasing. So it's starting to look like maybe 4 is going to be a minimum, but let's see. First we have to determine a number now that's on this side. So a nice number to choose that's bigger than 4. You guys could choose 5, 10, a million, doesn't matter. well, maybe don't choose a million, but let's choose 5, let's say for instance. So I've got 4 times 5 minus 16. Well, it's going to be 20 minus 16, which is 4. Now again, I don't care about the 4. All I care about is that it's a positive. If it's a positive, that must mean my slope is now going up. So looking at that diagram and thinking logically, 4 has to be a minimum. Because remember, critical values are either minimum, maximum, or inflection points. So we've got this here, and basically our graph is going to look something like this. All right, now the last one, this number 3, and it's saying in our question, for each of the following functions, state the intervals of increase and decrease. This, unfortunately, is what a lot of students forget to do. So we need to basically summarize what we've discovered here. This is going to be number 3. Now, an interval, if you guys remember back from, I think it's Learning Guide 1, where we talk about intervals, where I use the open brackets and the closed brackets. Okay, just as a note, we're pretty much only using open brackets from now on, okay, because we're not including that point. So I can say that my function is, let's say, decreasing, first of all, in this section, right? This is where my function is decreasing. So this is obviously going all the way to negative infinity up to 4. So we would just say negative infinity up to 4, not including either or. Okay, that's why we use the open brackets. We know that it's increasing, obviously, 4 to positive infinity, because we're looking at this side right here. This also means, just as a note, x equals 4 must be a minimum value. Now the question also says, okay, what are the intervals of increase and decrease? Good, we've got that. That's part of our answer, so I'll put a box around it. And determine the local maximum and minimum values. Well, we know that x is equal to 4 is a minimum, but what we don't know is what is the actual minimum value. And when we're talking about that, we're looking for y. So the last step that we're going to do here, I'll just call it number 4, find our minimum value. And now important, we have to go back to our original question, guys. If I use my y prime, that's going back to my slope, and that's not what we want. We want a coordinate. So y is equal to, and obviously we're going to plug in 4 for our x. 4 squared minus 16 times 4 plus 39. And when you guys evaluate that, you're going to get the answer of 7. So that means our coordinate is 4, 7, and that is our minimum. So it's saying, what would the sketch of this function look like? Well, automatically we all know that it's going to be a happy face because of that x squared. And we also know that our minimum value is 4 and 7. So that's going to take us right about here. And if this is a happy face graph, actually let me count 1, 2, 3, 4, 5, 6, 7. Yeah, that's good. And a happy face graph, it's going to look something like this. Okay? So that's our first derivative test. It literally allows us to draw our graph, which is really cool. So let's keep going with that. Let's take a look at B. So we're still doing the same kind of question. It's saying that it wants us to find the increase and decrease, also find out is this a maximum or a minimum, so on and so on. Now here it's saying, watch for undefined values for x. Now that's a big hint. The minute that you have a variable in your denominator, you automatically know that you're going to have a critical value. Because remember, x minus 3 can't be equal to 0, so therefore x cannot be equal to positive 3. What does that mean? I have a critical value at x is equal to 3. We know that that's going to be an asymptote, a vertical asymptote. So that's the first thing that we want to do. Now we still want to check for other critical values. Okay, now remember critical value, take the derivative, set it equal to 0. So let's take the derivative of this. Now remember this is like the quotient rule, right? So I'm going to take this, times it by the derivative of that, which is 0. So I don't need to include that, minus 2 times the derivative of this, which is just 1. over our denominator. Sorry guys, and I can put that over my denominator squared. So this is just going to simplify to negative 2 over x minus 3 squared. And again, we're going to set that equal to 0. Now looking at this, is there a solution? Obviously not. Negative 2 divided by anything is never going to give us a 0. So no solution. Okay, so that means our critical value is x is equal to 3. So we're going to see what's happening there. Obviously, that's not going to be a point on our graph because it's a non-permissible value, but we're going to look to see what's happening around that. Okay, all right. Number 2, in order to find out what's happening around that, remember this is where we use our test intervals. Okay, so I want to choose a number that's less than 3. Well, why not 0 again? So let's do that. And remember, we're using our derivative because we're looking for slope. So I've got negative 2 over 0 minus 3 squared. So that's going to give us negative 2 over 9. Again, I don't care about 2 over 9. I just care about the negative. So that tells me my slope is decreasing and my graph is decreasing there. Let's choose a number that's bigger than 3. 5 perhaps. 5 minus 3 squared. So that's going to be negative 2 over 4. Again, I don't care about 2 over 4. All I care about is that it's a negative. So looking at this, guys, right away, some of you might think, ooh, 3 must be an inflection because it's continuing to go down. However, x cannot be equal to 3. So our graph on this is going to look a little bit different. But again, and you can put that in your calculator if you want. Don't ever hesitate to take a look at this graph, obviously, when you're learning. And you guys are going to see kind of a funky looking graph here. But again, we need to answer these questions. Where is it increasing? Where is it decreasing? And what is the actual maximum and minimum? So let's answer those questions. Oops. And then, like I said, on your own, you go ahead and plug that in your calculator. You can see what it looks like. Now, number 3, again, I want to see where is my function decreasing. Well, it's decreasing pretty much everywhere. So we can say function is decreasing. Now remember, you can't include that 3. So I'm going to have negative infinity up to 3. And remember that little union sign there? 3 to infinity. So that would be one of our answers there. And the last one, it asks for, okay, well, what is the maximum or the minimum? Because I don't have a critical value that actually exists on my graph, therefore, we don't have a maximum or minimum. So we can just say because x equals 3 is a non-permissible value, there is no max or min. Okay, and again, feel free to look at your graphing calculator here. I'm going to move on. You guys can do that on your own. Now the next one and the last one here, I encourage you again, pause, try it yourself. This one's going to have a few more critical values, which is good. And you'll see, ooh, there we go, come on out. You'll see that you may also want to use your unit circle here for this one, okay? All right, so first thing we need to do, always find those critical values, and we find that by finding the first derivative. So let's do that. Okay, good old trigonometry. The derivative of sine is cos. So we've got 3 cos of x. Now if I want to set that equal to 0, okay, so now I'm looking for when is cos of x going to be equal to 0? Well, obviously we've got our pi over 2, because remember cos is our x value. So we know it's going to be pi over 2, and it's going to be 3 pi over 2. So x is going to be equal to pi over 2 and 3 pi over 2. So this one we actually have 2 critical values. So step number 2, remember we plugged that on the number line. So I've got pi over 2, and we've got 3 pi over 2. And again, I want to use our test intervals. Okay, so I take my first derivative, and let's plug in a number that's less than pi over 2. How about 0? So 3 cos of 0, well, cos of 0, remember, is 1. So that's going to give us 3, which is positive, which tells us this is a positive, and our slope is going up. Let's choose something right in the middle of pi over 2 and 3 pi over 2. A good example would just be pi. So 3 cos of pi. Okay. Now remember, cos of pi is -1 here. So that's going to become -3. Again, that negative is all I care about. So guys, I want you to stop here for a second and think, okay, if my slope is going up and then it's going down, what is pi over 2? It must be a maximum. So you can see it so clearly. All right, and the last one, we want to do something bigger than 3 pi over 2. Well, something good would be maybe 2 pi. Okay, so again, 2 pi is just going to give us our 1 right here. Okay, and we times that by 3, positive. So that must tell us that 3 pi over 2 must be a minimum value. Okay, hopefully that all makes sense so far. Now, what I'll try and do is get rid of this guy. Ooh, sorry. Ooh, get out of here. Here we go. And we'll erase this. And now let's answer some of these questions. So this is going to be, what are the intervals of increase and decrease? So we'll call this one number 3 in a different color. So the function is, let's start with increasing. And I've got 2 sections where we're increasing. That's going to be from -infinity up to pi over 2. And it's also going to be 3 pi over 2 up to positive infinity. Obviously, then it would be decreasing from pi over 2 up to 3 pi over 2. Okay? And you might be thinking, okay, well, why am I saying increasing and decreasing? What's the point of that? Again, this is showing our slope on our graph, which again is directly related to our maximum and minimums. So the intervals of increase and decrease, guys, you're going to see that quite a bit on your assignments. So make sure you know how to do this. I've seen so many students, it's so simple, but just not paying attention to it is the problem. All right, now the last question was asking, what is our actual maximum and minimum value? Okay, so remember, if I'm looking for an actual value, I need to go back up to my original equation. So the first one, let's take that first critical value, plug it in. So 3 sine pi over 2 plus 2 is going to be equal to 3 times 1 plus 2, which is 5. So remember, we said that this is a maximum. So our coordinate would be pi over 2, comma 5. So that's one of our coordinates. The last one, 3 pi over 2. So I've got 3 sine 3 pi over 2 plus 2. And that's going to be 3 times -1 plus 2, which is going to be -1. So remember, that one was our minimum value. And we've got 3 pi over 2, comma -1. All right. So guys, you can see, practice, practice, practice. See the help desk if you have any questions. Good luck.